Good morning and welcome back to the program. Today we are learning all about science and technology, and that includes some pretty cool experiments. We've already had fun. Professor Doug Mulford has a mini demonstration ready to go. Welcome, Professor Doug. This is going to be fun.
This is a lot of fun. I love science. It's a great opportunity to share science and that love for science. So I got two things that I want to do today. Now, the first one is one that many of you have had a chance to play with before, and that is changing your voice with helium. Now, the helium molecule, or the atoms, are light, so they're moving very, very fast. They're moving faster than the air around us. And so when we breathe that in,
and I gotta talk, your voice sounds a little bit different. It's a little bit of a Munchkin thing going on there. Now, most of you have had a chance to see that and hear that before.
okay, get that cleared out.
I don't care how many times you do that. Whether you're young or old, that is fun.
That is a lot of fun.
It's awesome.
Now, most of you had a chance to see that. What most people don't get a chance to see is this is part of the experiment. So this is sulfur hexafluoride. These molecules are really big. So as they're larger at the same temperature, they're moving slower. So instead of making my voice go up, it's going to make it go down. So once again, I'm going to keep trying to talk in a very monotone voice. We'll see what happens here.
And now when I talk, my voice goes the other direction and it sounds a little bit lower. And it's a lot of fun to play with. I love science.
Okay, had to get that out of my lungs.
Oh, my goodness.
It's kind of fun to see it go both directions. Wow, you can still hear it. Okay, now the next one I want to do is also to look at what the effect of temperature is on different materials. Now, you saw some dry ice a little bit earlier. I have a container here of liquid nitrogen. This is 77 Kelvin. It's minus 200 degrees below 0 Celsius and minus 320 Fahrenheit. Really cold.
Yeah,
so
really
I'm
cold.
going to look at three different things in the liquid nitrogen here. One is that I have everyone's favorite around this time of year, Marshmallow Peeps.
Perfect.
So let's go ahead and take one of our Marshmallow Peeps.
Should I put my glasses on?
Please put your glasses on.
I'm learning how this works.
All right, so we're going to drop a couple Marshmallow Peeps in here.
Okay.
And put those in. Let those sit a little bit. You're seeing what looks a little bit like a cloud here. It's actually water vapor from the air. It's condensing. And so we're seeing that. In fact, if you blow into it,
oh, wow.
a nice cloud there.
Very
Love
cool.
Science. All right. We're also going to take a racquetball. This is a standard bouncy racquetball. Put that one in.
Okay.
And then everybody loves balloons. So I have a standard balloon that would be used to make balloon animals or twisting or anything like that. Almost took me longer to learn to blow that than do most of the science. All right. So now we're going to take this long balloon. It's about 3 feet long, and we're going to put it in here, the liquid nitrogen, and see what happens.
Really? All right.
So let's put this in here. So this whole big balloon.
What kind of concoction are you making here?
It's science soup.
A science soup, okay.
So that goes down, and the entire thing fit into that container. So when we cooled the gas down, it took up less volume, and it shrunk down, and I was able to fit that whole 3-foot balloon down into this little container. Best part about it is it's reversible, but you have to be really careful. This is so cold it could burn you, so I have special gloves for handling the cold temperatures.
Okay.
And let's go ahead and get our balloon back out. Come here. All right, and see a little bit of the nitrogen there. And the balloon will warm up, and it should go the opposite direction as well.
Oh, my goodness, that is so cool. Oh, no way. What? How did you do that?
That's the magic of science.
Look at this. It's got a dog. You didn't tie it that way, though, when you put it in, did you? Or did I just not see that?
Part of the mystery of science. You have to come down to the
You're
expo
like a
to find out how it happens.
Yeah, you're like a science magician here.
All right, so I want to show you what happens to this peep. Now, I know that some people eat peeps. I actually just prefer to do experiments on them. And so I'm going to show you what happens when it gets cold. So I'm going to get this out of the way.
Okay.
And I don't want to break your nice table here, so I have a wood board.
I don't want that to happen to you either.
No. All right, and so we're going to take our peep, and we're going to take him out.
Okay.
And there's our peep. Oop, he lost a little bit of his tail. That's the minor details that are problems.
Such is life.
And science is always better with a sledgehammer.
Yes.
So here we go in 3, 2, 1. I love to do that to peeps.
When have you seen a peep that hard? Unless you just left it out for like over a year.
Yeah, even then, you've got to get it this cold, and it will do that. And then the racquetball will also shatter. I don't know if we're going to be able to see this on camera, so I'll have to break it first, and then we'll see what happens. But I'm going to try to bounce this again. Oh! And it made a nice loud sound, because every rubber has something called a glass transition temperature. I got it so cold that it behaves like glass. But the neat thing about it is it's actually reversible. So as this warms back up, get a little bit of thermal energy here, warm it up, it now goes back to being flexible again.
Let me see that.
So it goes back and forth. That one's still
a little chilly,
cool.
but
there
hey,
you go.
yeah, okay.
You got
wow.
flexibility there. As it warms up, it'll go
little
all the
bit,
way back
yeah.
to being completely rubbery again.
Very good stuff. I mean, Professor Doug, this is really cool. I had a lot of fun with this one. Very, very
much.
fun. Thank you for
very
being
much.
on the program.
Yeah.
We can't wait to come see you at the show, at the big event as well. Hey, and when we come back, see this right here? We're making paper like this. The folks from Georgia Pacific will show us the science of paper making. More fun right after this break on Public Affairs on Peach.